go for Galilean transformation. Galilean transformation. This is our first thing we have to learn in today's class. The rest part was just a basic definition or brush up thing. So Galilean transformation or Galilean frame, we have one inertial frame. Let's say this frame is S frame. And obviously we have this X axis, Y axis, Z axis. This frame is inertial in nature, which means it can move with respect to another frame. I am not concerning about that frame. I am starting with S frame actually. And then I will just define a new inertial frame that is identified as S dash frame. So this frame is S dash frame. And what is beautiful part? This S dash frame have velocity v with respect to S in x cap direction. So I am just putting I cap here. So this S dash is moving with respect to S in x direction. Means it is just coming like this. At this particular point, this is your t is equal to 0. And after time t, this S dash will be have this particular situation. So this x and x dash will coincide to each other. This is my y dash, this is my z dash. So this is two frame. So what I can say, if I am saying S dash is moving with respect to S, can I also say S is also moving with respect to S dash? If I am saying S dash is moving with respect to S, can I say S is also moving with respect to S dash? Yes. What will be velocity of S dash with respect to S? That is V in which direction? I cap direction. But if I will change, what is meaning of that? Velocity of S dash with respect to S is V in I cap direction. And same time, velocity of S with respect to S dash, that will be minus V, obviously in I cap direction. Means if observer will sit here, then what he will see? He will see S will be rest with respect to him, and velocity of S dash will be V in positive X direction. Let's say this observer is X, but there is another observer, and this observer is Y, and if he is sitting on the S dash frame, what he will see? He will see S dash is rest with respect to him, but S is moving in a opposite direction with the same magnitude. And you can have feeling of this particular thing when you are moving on a train. When you are sitting on train, what you will see? You will see that platform are just moving in a opposite direction. But with respect to platform, your train is moving in this direction. But if you are sitting on train, then you will see that your platform is moving in opposite direction of the train. Have you seen this thing in a daily life? So this is the exactly same thing we are just writing in term of mathematical language. Now, what we have any point in a space. Let's say this point in a space is a point. Any point in a space. And that point is a point. What we are going to do, we are just giving the coordinates of this point with respect to these two origin. So this is origin of S and this is origin of O dash. After time t, what is meaning of that? At t is equal to 0, we will start from here. And after time t, SD will be move up to this distance. The origin will move from here to here. The origin of S dash will move from here to here. And we just want to give the coordinates of this point, this particular point A. I can say this coordinate is x, y, z from S frame. The same coordinate is actually x dash, y dash, z dash from S dash frame. Are you people comfortable with this notation? Everybody?
Yes, sir.
Yes, sir.
Okay. Just you can comment if you are not going to understand. Okay. Okay. Now, what is my duty? My duty is that after time t, I have to just write the relationship between x and x dash, y and y dash, z and z dash. So we have to just write the relationship after time t. So what will be this distance after time t? Can you please tell me what will be this distance?
VT.
V into t. Very simple. What will be this distance according to x? This will be x dash. What will be this distance? X. You will just see this point in this particular length scale. है ना? So what is relationship between x and x dash? Can I say that x is equal to x dash plus vt? लिख सकते क्या?
Yes.
Yes.
Okay. And what about y and z? What about y and z?
Y dash, Z dash.
Obviously, there is not any relative speed in direction of y and z. So you have y is equal to y dash and z is equal to z dash. So we have just written this particular thing. Now, what is meaning of that? Meaning of that, if I have independent variable x dash, y dash, z dash for given value of velocity or speed and time, I can easily tell about what is value of x, y and z at the same time with this particular relationship. And this relationship is identified as inverse Galilean transformation. What is Galilean transformation? If I will write x dash, y dash, z dash, what will be this value? क्या होगा ये x dash को x के फॉर्म में कैसे लिखोगे?
Minus.
You will just write x plus minus vt, isn't it? This will be your relationship. Why I am saying minus vt? I will just explain you. Obviously, y dash is equal to y, z dash is equal to z. Obviously, this thing is nothing but x dash is equal to x minus vt. Don't worry. Now, let us just try to see this equation and this equation very nicely. Now, this thing is nothing but position of particle with respect to s. So this thing is position of particle with respect to s, isn't it? And this thing is nothing, position of particle with respect to s dash plus what is v? What is v? Velocity of s dash with respect to s into t, isn't it?
Yes, sir.
That is the same thing. So now, if we will see this particular symmetry, what we are writing? The position of particle with respect to s dash is equal to position of particle with respect to s, and hence you are changing s dash to s. Then you have to also change s to s dash. So I have taken this plus sign, and we have position of particle s with respect to s dash after time t. And what is relationship s dash to s and s to s dash? What is relationship here? क्या रिलेशनशिप है इन दोनों के बीच में?
minus opposite.
What is relationship between this thing? You have
Direction.
velocity of s dash with respect to s as v, then velocity of s dash with respect to s is nothing but minus v. So this minus sign will automatically come into picture, isn't it? But symmetry will always preserve. This is very interesting. This is very interesting. Are you getting this thing very clear and loud?
Yes.
Everyone? Okay, just try to do one basic problem, then we will move ahead. Okay? एक सिंपल प्रॉब्लम करते हैं, देखते हैं क्या है. You just see all s and s dash. Let's go for some coordinates and we just try to see what is going to happen. Suppose we have s dash frame and there is 2 point. Let's say the point is A, its coordinate is 1 0 and this point is, let's say 0 1, and this is moving with velocity v is equal to 1 meter per second, and this s dash is moving with respect to s. This s dash is moving with respect to s with velocity v is equal to 1 meter per second. So what will be the position with respect to these two position? What will be these two position with respect to s after time t is equal to 1 second? My question is that what will be coordinate of A and B with respect to t after time t is equal to 1 second. Everything I have deliberately taken 1 second. So what we have to do? We have to just follow this thing. And we will just try to see which particular thing is going to preserve. And this is very important for the next level of understanding. Let's try to do this thing. करें क्या इसे? You people are not responding. Why? चलिए क्या होगा? Can I write this coordinate as x1 dash is equal to 1, y1 dash is equal to 0?
0.
Yes. So what
Yes,
will be x1 is equal to x1 dash plus vt? लिख सकते हैं क्या? According to Galilean
sir.
transformation. So what is x1 dash? 1 plus v is equal to 1 meter per second and t is equal to 1. That will be 2. And what will be y1? What will happen to y1? y1 is equal
Same
to
to
y1
0.
dash. That will be 0. So from S frame, अगर S frame में आप देख रहे हो, then this point will appear somewhere something like 2 and 0. Now let's try to go for this particular point. Let's try to go for this particular point. So what will happen to this particular point? x2 dash is equal to 0
0.
and y2 dash is equal to 1.
1.
So what will happen? x2 dash is equal to x2 plus vt, and that will be, what is x2 dash? 0 plus 1 into 1, that will be 1 unit. And what about y2 dot? y2 dash is equal, sorry, y2 is equal to y2 dash, and that value is equal to 1. So this point will be something 1 and 1. So x at 1 and y at 1. Something like this point, isn't it? 1 and 1. So this will be after time t, the same point, this point and this point will appear. This will be your A point and this will be your B point. And this will appear with respect to S, just due to this coordinate transformation. But now, if you are going to check what will happen to this distance, what will happen to this distance with respect to S dash, and what will happen to this distance with respect to S? What should be your answer?
Contraction.
It will be same or contract or bigger. What will happen? So just try to see this distance with respect to S dash. So we can use the distance formula. With respect to S dash, we have 1 minus 0 whole square, 1 minus 0 whole square, plus 0 minus 1 whole square. This is root under. What will be this value? Root 2.
1, root 2.
Root 2. Similarly, we will just try to see this particular thing, the distance between A and B. Let's go for this. Here we have 2 minus 1 whole square plus 0 minus 1 whole square root under. What is going to happen? क्या मिल रहा है आपको?
Root 3.
Root 2.
Root 2.
So you can see this is distance from S frame and there is distance from S dash frame. Even if the point is appeared entirely differently from S frame and S dash frame, this point is for with respect to S dash frame, the point A is along x-axis, the point B is along y-axis. But with respect to S, the point A is along x-axis, but it will just going to shift from origin. But it will compensate it by the point B, and it is just going to shift from y-axis. But the best part is that these two distance is going to preserve. This is all about Galilean transformation. This is all about Galilean transformation. So you can transform, and this transformation is all about inertial frame, because you are just moving with constant velocity, and you are just moving with constant velocity. The observer sitting on S dash will see the different point. Observer sitting on S will see the different point, but both will measure the same distance between these 2 points. But what will happen when I will just change this speed? V is equal to 0.1 c, and c is the speed of light. Then what is going to happen? We will see when we will go for Lorentz transformation. Are you people comfortable up to this point? Everyone?
Yes.
This should be answered. इसका हम आंसर देंगे when we will take the same example. Don't worry. We will take the same example and we will just try to give the answer what is going to happen, and all physics is going to change. But before that, let us go for a relative speed for the Galilean transformation, and then we will discuss why Galilean transformation is not very adequate when we are moving with the speed of light. Are you people comfortable up to this point?
Yes, sir.
Everyone? Ayushi?
Yes, sir.
Okay.
Yes, sir.
Mehak, are you comfortable? है ना, क्योंकि मुझे आपका चेहरा दिखाई नहीं दे रहा है, then I am just blank. Okay? जब तक आप थोड़ा रिस्पॉन्ड नहीं करोगे, it will be very tough to me. है ना? You can see me, but I cannot see you. So at least you should tell me, sir, फिर से बताना है या क्या चल रहा है. Agreed? Are you people comfortable up to this?
Yes, sir.
Everyone? Okay, chalo. Let's go for relative speed in Galilean transformation. And then we will create a very nice story such that in next class we can easily go into Lorentz transformation and we can start a very new physics. Now, the same thing is here. There is S frame and this frame is inertial one. There is another frame which is S dash frame, and S dash frame is moving with respect to S with velocity v. At t is equal to 0, both have same origin, okay, and they have common x-axis for the simplicity, nothing else. So they both have common x and x dash. This is y, this is z, this is y dash, and this is z dash. Now, the story is entirely different. We have the point with respect to s dash, and this x dash is x dash, y dash, z dash. And this point P, let's say this point is P, or let's say A. This point is moving with respect to S dash with velocity, let's say ux dash, uy dash, uz dash. These are statement from S dash. So S dash is moving with respect to S, and this point A is moving with respect to S dash. So can you please tell me what will be your ux dash? What is definition of ux dash?
Velocity with respect.
What is ux dash? Ux dash is nothing but dx dash upon dt. Change in distance with respect to this origin by time. Time will be same for both s and s dash for the Galilean purpose. But obviously for the Lorentz purpose, it is going to change. So ux dash is equal to dx dash upon dt. Uy dash is equal to dy dash upon dt. This is definition. Uz dash is equal to dz dash upon dt. Now, what will be speed of this point with respect to s? So with respect to s, this coordinate after time t plus dt is something like x, y, z, and this will be ux, ui, uz, and this is with respect to s. And we have relationship between s and x dash after time t that will be given by inverse Galilean. So x is equal to x dash plus vt. And we can differentiate it. So we have dx upon dt is equal to dx dash upon dt plus v. And what is dx upon dt? Dx upon dt is nothing but the speed measured with respect to this origin. So we can define ux is equal to dx upon dt, ui is equal to dy upon dt, uz is equal to dz upon dt. And now we can say this ux is equal to ux dash plus v. And we can write this particular thing as velocity of a point A with respect to s must be equal to velocity of a point A with respect to s dash. And what is v? Velocity of a s dash with respect to s, isn't it? For x condition. And for y, there is not any problem. Dy, y is equal to y dash. So dy upon dt is equal to dy dash upon dt. So you have ui is equal to ui dash, isn't it? And similarly, z is equal to z dash. So we have dz upon dt is equal to dz dash upon dt. So you have uz is equal to uz dash. Now, if I will tell you this is my known variable or this is my independent variable, how you will write the dependent variable? How you will write it? कैसे लिखोगे? ux dash is equal to क्या लिखोगे? Obviously ux plus minus v, something like this. So what is meaning of that? Velocity of a with respect to s dash is equal to velocity of a with respect to s plus velocity of s with respect to s dash. If I am changing s to s dash, everywhere I am going to change with s to s dash. Isn't it? This is very important. This is very important. Why? Because if observer is sitting on s, he will see s dash is moving with v velocity. Then if observer will sitting on s dash, he will see s will moving with v speed but in opposite direction. That is all about this one. But the symmetry is exactly same. Look at a with respect to s, a with respect to s dash with respect to s. If I am changing this s to s dash, then everywhere the s will changing to s dash without anything going to change. So you should understand this particular thing. Are you getting my point? क्या हो रहा है? In a physics, there is nothing called negative sign. If you are talking about velocity and in term of vector. In term of vector or velocity, you are just saying same magnitude but in opposite direction. And the act is all about positive thing. Obviously, numerically it will be something like ux is equal to ux dash is equal to ux minus v. Numerically, you can write something like this. But as a physics thing, we have to always go for this one. Now, onto this particular transformation, we can create one very simple story and we can see what will happen when speed of light will come into picture. यहां तक clear है ये? Everyone?
Yes.
Okay. So let's try to see what is going to happen. एक सिंपल से स्टोरी क्रिएट करते हैं. So should you give 5 minutes more? 5 मिनट और दे सकते हो?
Yes, sir.
है ना? 5 मिनट
Yes,
और लेते हैं ताकि कल हम लोग फ्रेश शुरू कर सकेंगे, है ना? Because these all thing I know you people know very well, but it's my duty that I have to just start from the scratch ताकि कुछ चीजें छूटे ना. Just let's try to create one story, very simple story, and we will just try to see what is going to happen. Suppose there is a train and there is a one platform. Let's say this is platform, and this train is moving with velocity vt with respect to platform. Okay, so velocity of train with respect to platform is vt and it is moving in positive I cap direction. In positive I cap direction. Just a simple story. Now, there are two observers. Let's say the first observer is one small child. Let's say he is first observer. Let's say his name is X. There is another observer. He is his uncle. Okay, and he is Mr. Y. And X is rest with respect to train. Means he is just sitting on a train. X is not moving with respect to train. Okay, X is just sitting on the train on some berth. And he has one beautiful car, toy train, which can be maneuvered by the remote. Remote car, it can be maneuvered by this. So he has one toy train. Okay. And this toy train has velocity u1, u2, u3. Means in x direction it has u1, y direction it has u2, And keep it simple, it is just moving only in x direction because we have less time. So it is just moving along x direction, u1 0 0. You can just tell u1 0 0. So he has one remote control machine and he can just measure what will be speed of car. And he just say, okay, with respect to me, the speed of car is u1. And he called to his uncle and he say, uncle, what will be speed of car with respect to you? He just call him and uncle have to give the answer. What will be speed of this particular car with respect to uncle? Uncle just no Galilean transformation, and what he do? He just fix a platform as S frame. He just fix the platform as S frame. And this train is moving with respect to platform. So he just say the train is nothing but S dash. And this toy car is moving with S dash. That means uncle give the notation velocity of S dash with respect to S is actually velocity of train with respect to platform is nothing but V, obviously in I cap direction. Now, this particular toy train have a speed with respect to x and x is rest with respect to s dash. So it has a speed with respect to s dash. So velocity of car with respect to s dash is actually ux dash because it is only moving in x direction. So this value is u1. Uncle no Galilean transformation and he have to calculate velocity of car with respect to s. So obviously with respect to s, he have to tell this notation as ux. And this ux from the Galilean transformation is ux dash plus v. We have just done this calculation. So according to uncle, what will we answer? Ux dash is equal to u1. V is nothing but vt actually. This is vt. So this will be vt. So this is the answer given by uncle and this is absolutely correct answer. Now this child just take another apparatus to play and what he does, he just remove this particular thing and he take a laser gun. And what will be speed of laser gun? Laser light? Obviously speed of light, isn't it? There is laser light and it is moving with the speed of light. And then this person X again measure this speed of light or some photon or some laser ray with respect to himself. Obviously this is C. And again he asked uncle, uncle, what will be speed of light with respect to you? Then uncle say, okay, I have done same thing. And uncle know only Galilean transformation. He has not any information about higher studies or relativistic mechanics. He just apply Galilean transformation. So what is going to change? This will remain same. Only this is going to change with respect to x dash. This speed is c. So he just put u1 is equal to c. And now this will be c plus vt. And c is a very good number. This number is 3 into 10 to the power 8 meter per second, isn't it? Now this ux is equal to c plus vt. Is that this answer is correct or false? This answer is correct or false? This answer is absolutely false. Why it is false? Because there is one experiment, that is Michelson-Morley experiment. There is one experiment which is Michelson-Morley experiment, which reveals which reveals that speed of light with respect to any inertial frame is always c. It's c, and that c is nothing 3 into 10 to the power 8 meter per second. So why this answer is wrong? So there is some problem. There is some problem into formulation of Galilean transformation. So we need to work something else, and that will be the initiation of a special theory of relativity. So tomorrow's class, we will just go into what we have done. We will just summarize that, and after then we will go into new level of transformation, and that is known as what? Lorentz transformation. And from tomorrow, you will just learn something new concepts. So up to this, if you have any doubt, you can ask